So we're online. Yes. All right. Yes. Hello, everyone. Welcome back to the second day of the ship navigation and route optimization webinar. We had some interesting presentation yesterday, and we'll have some just as interesting ones today, both from service providers, from independent consultants, and also from shipping operator and owner. So the thing about ship navigation and route optimization, so we are looking a lot on safety. So safe navigation and optimized ship routes, that's essential for ship and crew safety. And efficient ship routes and navigation, it's not only crucial for safety, but it's also benefits for fuel consumption and time, which helps owners to meet financial and environmental goals. Yesterday we had some topics. We'll have some topics today also, and some of them are on guidelines for safe ship navigation, autonomous ship reality, future AI-based navigation systems, ship speed variation, and minimizing fuel oil consumption and time by route planning. Also, maximum efficiency by the data analysis and weather forecasting methods for voyage efficiency. Our mission is to identify cost-effective solutions to enhance vessel safety and efficiency while protecting the environment. So we are very happy to welcome you to this day's discussion. So the sponsors for the event today is VesOPS, it's DeepSea Technologies, and it's OneOcean, and you'll hear presentations from all of them today. We will be presenting with 5 presenters. We'll be finished around 16:30 with the presentations, and then there'll be a Q&A session after the presentations are done. But if you have any questions and remarks during the presentations, feel free to put them into the Q&A section that's available for you while you listen to the presentations. So, in fact, I'll start the presentations today. So, I'll just share my screen so you can see it. Let's see this one. So my name is Soren Hansen. I'm moderating the event today, but I'm also working within this area here. I've been working in the industry for many years. I have a background as a professional seafarer, and then I started working with vessel performance, voyage optimization, and for different companies. And today I have this independent company called VesOPS, which is a company that handles performance specifically on the sustainability side. And I'll just give my take on how to handle or what should be handled in ship navigation and route optimizations in the product and in the market that we see today. What's the necessary items to include? I'll change my screen here. So what's important here is the safety of the ship, the crew, and the cargo. That's why we have this. We started with weather routing many years ago to be able to predict what was the weather that the ship would encounter while it was doing a voyage, particularly for the safety issue, so that you didn't have any losses of cargo and ship and crew. And then we have also this optimization thing where we are looking for the most optimal route for the ship. That's for time, speed, and consumption. That's for sailing in the best weather, and that's for getting out of the port in time and getting to the next port in the right time. So for that we need data analysis, and there are different analysis options. We saw some of them yesterday from some of the providers that presented yesterday. And then, of course, that should lead to some sort of decision support along a planned route, a decision support for the land organization, but also decision support for the crew on board, because they are the guys who are in the vessel, who are sailing with the vessel, and who meets the bad weather and have to do all the operations on board. So it's important that they have at least some good communications with the ones who plan the route, but also are part of the planning themselves. If we look at the safety issues, then it's decision support that we want to avoid severe sea states, because severe sea states make damage to the vessel. We have unfortunate motions. For some vessels, if we look specifically at the container vessels, we have seen a lot of container losses over the last year. Just over the last year, we have seen thousands of containers running overboard while a container vessel is sailing. So we want to avoid that, and then we want to avoid damages to the ship and its cargo. And how can we do that? Well, we can do that so it's possible that we give some decision support to them. So in the long-term planning, we can predict something along a route, but also online or at the moment, can we do something that can make it easier for them to decide what to do when they meet some bad weather? So the crew handles the ship, and if we look at ships, they are becoming bigger and bigger, and specifically if we look at container vessels, they are becoming bigger, they are becoming wider, they have less engine power, and all because of a transport efficiency concern. The more cargo you can put on board a vessel, then the more transport efficient the vessel will be. And then if you are the navigator who has to take decisions and you're standing 40 meters up in the air, then it can be sometimes difficult, because you can't see the bow of the vessel, you can't see the stern of the vessel, and sometimes it can be difficult to decide what to do when you meet some bad weather. And when is the bad weather, in fact, because for some vessels, bad weather is one thing, and for other vessels, it's another thing. So size and heading and speed and weather is something that you have to consider when you're considering, is it bad weather or not. So you want to avoid these dangerous situations. And then you want to be able to predict some unfortunate motions, because where we saw the container losses on the last slide, it is because of unfortunate motions that the vessel is losing the containers. So typically what a shipmaster would do when he meets some bad weather, he would probably slow down. He would go with the bow up in the seas. And then if he's unlocking with the meeting period of the waves and the wave height, then and the stability of the vessel, because stability of the vessel is a concern also. And if you look at a container vessel like the one we see here in the picture, it's very stable. It has a high GM, so it has very abrupt motions. So there are very fast accelerations you'll see on a vessel like that. So when the captain goes up in the seas, he slows down, then he can meet what we call parametric roll. Parametric roll is high roll motions from side to side with very fast acceleration. And if the vessel or the containers on board the vessels are lashed with conventional lashing, then they cannot withstand the hard roll motions, and then they start breaking the lashings, and then you lose containers. But this is typically what a shipmaster would do. But if he doesn't know better, then he might meet these situations. So if we can put up some sort of decision support for him and say, okay, if you meet this weather and there are these unfortunate conditions, then you shouldn't go this and that way. You should go this and that way instead. So instead of having something that looked at what happened or what will look in the future, can we then make some tools for the crew on board that shows them what is it that you are encountering right now? And for that, we need to be able to measure at least the waves, and the wave, we need to know something about the wave, the height, the encounter period, and so on. So we need some sort of measurement of the waves. We can either do that by a wave radar, or we can put some measurement equipment that measures accelerations. And then we can set up some zones for in some sort of conning display where where the captain can see, okay, if I'm going with this speed, I shouldn't go in that direction because this is a dangerous zone for me. So an online prediction tool would be beneficial in a case where you are sailing with a big container vessels as the one as we see in the picture. So that's one thing. The other thing is we need some accurate and safe routing advice, because updated sailing information reflected in the routing advice, because the captain on board, he is making planned route ahead, and he's of course taking care of all the obstacles, and then he gets some routing advice on top of that, and the routing advice has to reflect that the captain's planning, and there has to be some alignment with the routing provider and the company procedures that's in fact available in the company. So that concern has to be addressed in the safety of the route planning also. And then the optimal route. What is the optimal route? Of course, you have to apply some weather, and then you can do some speed management and fleet planning based on if you have some weather and you know you're going from A to B. Then you need to know something about the ship, because some ships they are experiencing some weather that's bad for them, and other vessels are experiencing the same weather that's not so bad for them. So we need to know something about the ship. And then we need to know what's happening when the vessel is slow steaming, and we need to plan also for virtual arrival. That means we need to be able to see ahead if there's congestion in the port, which there are in many ports today. Can we then plan for an arrival where we can get to berth when we get there? And then, of course, that leads to speed and heading around the wind and around the waves. And then responses when you meet some bad weather, because one thing is that you can set a parameter that says I don't want to meet higher waves than 6 meters, but maybe 6 meters in the right direction is not so bad for the vessel. So you need to know something about the responses of the vessel when you predict something on a route for them. And then, of course, that leads to good communication between the operator, the crew, and the port where the vessel is going. So ship characteristics. This is something that I don't see captured in many of the routing software that we see on the market today. So a good seakeeping model, because the seakeeping model will say something about how is the vessel experiencing the weather, how is it performing in bad weather. So if you know that about a vessel, and you combine that with the actual cargo stability calculations, you would know how the vessel will react to different wave motions and different directions. And then it's much more easy for you to make a more precise prediction or precise advice for them when you're making a route or a route for the vessel to come on the next voyage. And then, of course, if you're looking at economy, then you, of course, want to minimize the fuel oil consumption, and then you need to know something about the speed and consumption and the fouling state of the vessel, so you know that at certain speeds and certain drafts, the consumption is this and that. And then you can add some historic data to support the ship model, so you have a model that's really capturing the actual vessel and its behavior in the weather. So the optimal tool in this case, it includes the good wind, waves, and current forecast models, the good updated ship model, a multidimensional optimization algorithm, an algorithm that doesn't only look at sea states and sea states height, but also look at direction, seakeeping characteristics of the vessel. And then you'll have a much more optimal route if you take these considerations into account also. And then a decision support function for route options. So if the weather is changing, if there are some parameters around the port arrival that's changing, then you need to have that added and updated to the route that you're going for. And then a good online decision support in bad weather, because we see, even though we predict something based on forecast models, then sometimes the weather is different from the forecasts, and then you have to have an option for the crew to know what to do in those cases. And then finally, the advantages, of course, of having this optimal tool is that it's the fastest, most safe and reliable route from A to B. You'll be able to maintain your schedules and save your fuel costs. And then you'll comply to contract conditions, because if you're in a charter party contract, you want to comply to the conditions that you have agreed on. And then you can avoid port congestion also. And then if you then add accurate communication to port and terminal costs, or terminal, then you can save on the cost for the port stay. And then finally, a very important long-term thing is you can extend the fatigue life of the ship structures while you have the ship in your operation. So that was just some thoughts on the good tools and what it is that we need for the good optimization tools when you're looking at route optimization. So thank you for your attention, and I'll be available for questions hereafter. And then I'll stop my screen sharing. And then we have another presentation. And the presentation is from DeepSea Technologies. It's it's Angus Whiston, who is the commercial director of the DeepSea Technologies. DeepSea's mission is to harness AI for the benefit of the shipping industry and the environment. And Angus, he wants to present his views on that. So please go ahead, Angus. The floor is yours if you'll share your screen.
Thank you very much, Soren. Firstly, thanks very much for that presentation. I think it was a really good introduction, actually, also to what I'm going to say now, because a lot of the themes you've already touched on, but I'm going to put it in a slightly different context. So, can you see my screen?
Yes, we can see it.
Great, thank you. I always like to check. So I have set myself a very ambitious task today, which is I'm going to try and convince you all three things. Firstly, that there is a right answer to routing, vessel, voyage optimization. Secondly, that we know what it is and we can already harness it extremely effectively. And thirdly, that we can prove it. And I'm going to attempt to do all of that in around about 10 minutes. So wish me luck. Speaking of ambitious things, I know that the title here, Performance Routing for the 21st Century, is in some ways a very ambitious title. But there's a very good reason why we're saying this. Now, as we all know, weather routing as a concept has evolved over the last, well, many decades. Maybe many millennia, possibly, but certainly in the modern form, many decades. And of course, it started with exactly as you'd expect, weather routing around weather. And then, of course, we start to add in some other parameters such as time charter rate, bunker cost, whatever that happens to be. But we as DeepSea Technologies certainly believe that there has always been something missing from this. Now, a little bit about DeepSea Technologies before we continue. We are, as Soren said, an AI company in maritime optimization, specifically voyage and vessel optimization. And we have been focusing extremely intensely with a research team of now 15 people on one particular problem in the industry, really, which is really accurately modeling vessel performance, because we believe that without that, you can do very little in terms of optimization. What is that missing bit that we believe in the weather routing industry, shall we say? It is, as Soren alluded to, how do the individual vessels uniquely respond to the weather? Because it can make a huge difference. And as a result, we turned our hand to creating a product called Vinther, which takes into account the individual performance of each vessel and puts it in the context of the weather and the voyage. And as a result, you can see that is performance routing for the 21st century. It is what it is. It's routing based on the performance of the vessel. You can see here just briefly, we actually take into account 19 parameters in the models for the vessel. And in a series of case studies that we've done, which we'll talk a little bit about in a minute, we've actually seen up to 12% fuel savings and sometimes much higher, but and on an average of 8 at the moment in terms of applying this approach to the routing problem. So here, as you can see on the right, is an example of a 3-dimensional model of a vessel. So you can see that at a fixed speed of 12 knots, this model is showing for a certain wind speed and a certain relative wind angle, the power that is required to drive that vessel forwards. Now, if you imagine 19 parameters going into these models, it is a task that is almost impossible without using extremely detailed AI modeling techniques. These are 2 actual vessels, Vessel A and Vessel B. And we've got 2 other models here. We've got power, relative angle, and speed of the wind at a fixed speed of 16 knots over ground and a fixed draft of 12 meters. You can see that already we've got so many parameters in there just to build these models and to show them. The model that is running our weather optimization system takes all of these parameters into account, and as a result produces millions of different opportunities in order to make savings. We can see here again, this is how these 2 different vessels respond differently to currents. And you can see that in both instances, they're actually quite different. As Soren said, the specific characteristics of each vessel are very important when we're considering making savings. Now, of course, we're not talking about making 60, 70% savings. If you can make 12% savings in today's world would be phenomenal, right? And that is why this intricate modeling process is what leads to the results. So we're going to dive just very slightly deeper into this. Why is this approach important? So here is all of the data that I've taken, by the way, in this presentation is from real life studies that we have done with clients across the course of the last year. I've taken here a very short voyage because one thing I want to communicate is when you take this kind of approach to performance routing, you don't require a huge amount of time in order to make the savings. It doesn't happen all in one go, in one lucky spurt. It happens continually, continual optimization. So here, for example, this is across the English Channel, 0.7 days traveling. And of course, because your route options are very limited, then the majority of the savings that we see in this route, which was done through our system Vinther, are as a result of the speed optimization. You can see that the route followed by the captain in red is very similar to the route that we optimized, but the speeds are very different. Now, what does this yield? So let's have a look. We can see at the top, we have the sailed time series for currents versus the speed of the vessel. And on the bottom, you can see the same voyage optimized using this AI-based system. So we can see a few things here. We won't dwell on it for long, but what can we see? We can see firstly that there is a lot of focus on an overcompensation on making the ETA. So we can see that the captain has gone faster during the first 2/3 of the voyage and then has dropped the speed right down in order to because he knows that he's going to make the ETA. And of course, it's a very natural, understandable, intuitive thing to do that, but it is certainly not optimal from a consumption point of view. We can also see a few other things. We can see on the left at the beginning, we can see how there is a significant focus on dropping the speed while there is a small increase in currents. And we can see that in general, there was quite a jerky movement in terms of the speed profile. Now, if we look below, once we've optimized this voyage, taking into account the weather and the vessel, then you can see what we come up with is a much more stable speed profile, taking into account the currents, working with the currents, and ultimately dropping the transitional effects of increasing speed or decreasing speed, along with a much more stable speed throughout the voyage. We can see a similar thing here with wind. I won't go into the details here, but again, the key point is that, amongst other things, humans tend to overcompensate for certain things, particularly if they're seen, such as wind. Whereas actually taking into account the forecast and the performance of the vessel, you can create a much more optimal profile for the voyage. And so on this particular example, what did this mean in terms of savings? Well, it was a very short voyage, as we say, 0.7 days traveling, consumption of 12.94 on the actual sailed route. And when it was optimized via Pythia, using exactly the same forecasts that the original voyage was done with, then it yielded a 9% fuel saving. Now, of course, you can extrapolate this up. This is a very short voyage, and say this kind of approach, again, incremental, continual optimization, has a huge impact on the power requirement and therefore consumption of each voyage. So I think that's hopefully taken us through point 1 and point 2, which is there is a right way of doing this, which is taking all of these things into account, the weather, the commercial parameters, and very importantly, the individual performance of each vessel. And of course, there are other parameters such as you might optimize for roll or for any other parameter. But basically, that approach of those 3 key things is the right answer, we believe. And secondly, I've given some examples, hopefully, of how it actually does it. The third thing is probably the most important in some ways, which is we can say all of these things, and maybe it makes sense in theory, but how do we actually prove that this improvement is as it appears to be? Well, of course, the problem with this whole sector, in some ways, is that it's incredibly hard to find a baseline. You say, we have saved 6%, we have improved by 6%. 6% versus what? Because, as we all know, you're always going against something that didn't happen one way or another. Right since the beginning, when we started doing this, we knew that this was a major problem to overcome. So with all of our clients, we go through a 3-step process, which is firstly, analyzing the quality of the data to make sure that any kind of assumptions that are made are agreed to be based on a very good foundation, number 1. Number 2, we will use our modeling to predict a series of things about the vessel which we had not seen before, a key one being consumption. Now, it's quite a magical thing in some ways, because once we have these models built, then we can actually present to you, to anybody, exactly the fuel consumption within 99% of typically, with 99% compared to what was measured from the flow meters across any route. And this is a very good way of showing the models understand the vessels, therefore let's put some trust in them. And then finally, using that same algorithm and those same models, which we've shown scientifically are a very good representation of reality, we can then do a full savings analysis based on past routes and then optimize routes using our system. Now, this whole process is something which happens quite quickly, but the outcome of it is people, including us. I mean, it's a wonderful thing. It really allows us to have genuine faith and find a baseline in how this approach makes those savings. And finally, we can throw some numbers around, like when we do this optimization for those routes, then we come up with an ROI, we come up with an average saving figure. And again, it's very scientific. I think probably it's better for me just to leave it there. This is an awful lot of information to put in one go, but I'm very keen to answer any questions. And certainly to start, if there's any debate around this kind of approach, we'd love to hear it. Thank you very much for your time.
Thanks a lot, Angus. Very nice presentation. Thank you. And very interesting what you do with the data here. Now you showed us a very short route. So I'm interested. So when you meet waves, also, do you have some AI models that includes the waves? Can you enlighten us a little bit on that?
Exactly. Yes, includes the waves. Not only the magnitude of the waves, but also the angle of the waves, and distinguishes wind waves from swell. I mean, any parameter, any data that we can get our hands on, we will feed into that model.
Okay, all right. So, and the forecast. So when you plan the route for a ship, you use some forecast data. Where do you obtain the forecast data from? Is it something?
Well, we take it from different sources, but I think we all accept that is one of the noisy bits in any of our systems. So therefore, for us, what we would say is it's absolutely critical to have a system that can re-optimize on a very regular basis. So, for example, whenever we route a vessel, we do an hourly re-optimization, and we also re-optimize in different ways depending on how the vessel is doing against the original plan in terms of speed, in terms of route, and constantly feeding this back to the vessel.
And you're optimizing on speed. So let's say we are looking at maybe if you're going up and down in speed all the time, are you looking at other optimization parameters, power, fuel oil consumption, or is it only speed that you're looking at?
Yeah, so we don't optimize. We optimize. We opt for consumption. But well, just see my internet is lagging a bit. We optimize for consumption. However, we do give instructions in speed or RPM. That's a flexible thing. But what we're actually doing is a full holistic optimization for consumption.
Okay, so it's not like I have to ask because yesterday some were looking at constant power. Are you also looking at power as the estimator?
It's very interesting. I was going to go into this a bit, but it was too much. So,
all right,
we will come out very. No. But I'd like to just say it's a very good question, because it seems that in the industry at the moment is one of the things that is really interesting people. Our view, humbly, would be that is not the right answer. In fact, if you have limited information on how forms and on the weather, then perhaps it's a half decent approach. Whereas if you can get that granular information of how vessels react to different weather conditions, and you can have re-optimization regularly enough, then you can create a much more efficient route without using a constant power or a constant consumption approach.
Interesting. Okay, thank you very much. But if you'll have a look at the Q&A section, there are some questions for you while we continue here. But thank you very much for your presentation. It was very interesting. Thank you.
Thank you.
So we'll go to the next presenter, and the next presenter will be Nicholas Bourque from from OneOcean. And Nicholas, he's the Chief Strategy Officer, and he's developing the company's future strategy and some visions to reinforce safer, cleaner, and more efficient working practices. It says in your bio, Nicholas.
Correct.
So please present. We are looking forward to hear what you have to say.
Good. Thank you. Thank you very much. Hi, everybody. Just get this time going. So yeah. So I guess so OneOcean, just to give a quick background on who we are. So founded 2 years ago following a merger between two companies in the navigation space. We have about 15,000 vessels that rely on our software on board. We're very much deal with ship managers and owner and provide navigational aid to decision software, compliance software on board ships. We deal with about 2,600 customers. And an interesting part that has been growing kind of month after month is we have about 7,500 passage plans. And these are fully digital passage plans. So they're kind of that middle ground between voyage instructions given by the commercial team or the operational requirements of that the owner gives or in the analysis. And these are companies that are doing end-to-end, not just from a compliance standpoint. And that's kind of how we looked at the issues around optimization, savings, efficiency, et cetera, across the broad topics. So that's very much kind of where we came. So how can we make voyage decisions simpler? So our product portfolio is 3 key categories. So compliance, so we have with DocMap and Log Central, process management. So DocMap being a document management very much used by the HACQ teams. Log Central being a whole suite of digital logbooks, from voyage logs to MARPOL record books. We own the largest environmental and emissions database in the world as far as environmental requirements worldwide. And we kind of wrap that up all on shore with the voyage planning and a weather and route optimization software. So very much when we looked at how do we address these questions, and we really looked at it, how can we decomplexify it on board? And what we found is everybody looks at optimization by how can we make more money on the pre-voyage, picking the right ships, making sure that the terms are all okay, and the post-voyage or even the monitoring during, but how do you operationalize this? If I'm telling a vessel to slow down or to accelerate or to, if there's a change in certain voyage conditions, what's the impact of that on board the ship, and how can we facilitate so that they can maybe consider more factors in the decisions and put them into actions quicker while remaining compliant. So this is kind of the model that we have. Is right now the red, green, blue boxes are kind of different workflows that you have on board ships or within shipping companies. And everybody's trying to source the information themselves and take the little bit of info that they need. And then everybody goes back and creates their own plan. So navigation through passage planning have their own plan. HSCQ and auditing, they kind of do that. And then you have operations, engineering kind of doing their own. But in reality, this is really difficult and not a lot of it talks to each other. So creating conflicts where you either increase risk because you're discharging ballast where you're not supposed to at a moment when you're not supposed to be doing it. So we very much kind of say, well, if you would to blend those lines together and create a tool on board where planning can be can happen together. So if you actually connect as inputs, the data, the regulations, ship processes, and the commercial requirements into a planning tool through linking it with what we call here dynamic events. So going beyond the passage plan of only plotting navigation points, but actually looking at a voyage plan as a timeline of events that need to happen. And you break that down into other ones. Well, it doesn't matter what change happens, your tool can react to it. Everybody gets clarity of picture as far as what needs to happen. And if you provide the logging and the reporting that goes with it, you actually get a continuous improvement loop, which we feel is a big part that's what's missing of this is what was supposed to happen. This is what happened. Great. This middle part that we play in with our software, with the OneOcean software, deals with why was a decision made? What was planned or supposed to take action at that time? And then therefore, as an output, you can look at continuing to monitor it, take action, analyze, and bring that into this whole digitization space of generating insights from it. When we started this, we really had 3 clear principles that kind of guided the past 2 years of work on our software. So data that works together should be easy to visualize. You should be guiding where to look so that mariners on board the ship can look at dealing with the issues themselves, not doing the paperwork. that's where that kind of automation change and data operability comes in. The simpler we do, the more we do that, the better and more time that frees up. And operationalize compliance. That's a really, really big thing. And maybe because we came at it with the knowledge of the HSCQ document management solutions and the logbooks, what we mean by operationalizing compliance is that it shouldn't be a thing that's on the side. It should be something that's actually weaved into the tools. So in the first presentation, we talked what happens if there's adverse weather. Most companies have an adverse weather checklist. Unfortunately, it's in the binder on the side. And why not weave that into? So during the planning process, if you're seeing you're going to encounter that bad weather, make sure that checklist is there and easy to access actually in the software, not something completely on the side. So what I want to do is just kind of dive into some of the, this was kind of our approach that we took. So we automated passage planning as much as we can. We'll show you kind of with some customers what we've been doing on creating operational events and operational schedules to share within the Voyage stakeholders. This has been relatively simple as far as an output, but as far as how much that kind of broke down traditional operational barriers for them to really look at the efficiency of their decision making, it's been quite huge. And then make sure that we blend all that together into the continuous improvement. So I'm just going to play a quick video here. Can everybody see the video?
Yes.
Yes, great.
Yes.
Now, yes.
So just bring it up here to 555. Yeah. So this is just the planning software that's installed on board the vessel. So quickly, just selecting 2 ports. We used as a weather service, and for the routing engine, DTN is our provider for this. And then quickly generating the route using specific control points. This is also ship specific, meaning that all the details, fuel curves, etc., for the vessel are all pre-programmed in, which also allows us to blend in the navigational elements for things like automatically calculating UKC, looking at tidal areas where safety could be an issue. This is all done automatically. And therefore, if you want to make a change, then you're not creating an enormous amount of hours to make those passage plan changes. It's all one click and you just recalculate. So this is an example of just kind of playing around with the specific route once it's been generated and looking at all the kind of navigation elements that you can put to it. So as we progress a bit further, you can then look at how can I optimize my route? So we do an optimization right in the software, looking at cost, time, a variety of different factors. And then you can have naturally all the playback functions. And this is a great start to how you would create your voyage plan. If companies prefer to use an external routing service, then we provide different types of import and we have different types of connectors for this. But that's kind of really the baseline of making this initial part as simple and as quick as possible. Let's go a bit further up. Yeah. So here looking at 2 or 3 different types of route, as I mentioned, cost and being able to analyze all of the above. And then you can quickly overlay information that would be required regarding on the right side here, any environmental. So for example, trying to avoid emission control areas, which we're just going to showcase here. So you have really the full database of being able to, if you would want to avoid those areas, what type of modifications you'd have to do. So that's pretty straightforward. So I'm just going to move on to the next video. And this, so then as you continue to progress through this decision-making process, so this whole voyage plan took about 15 minutes to do. And in reality, it takes quite a bit more time using more traditional methods. So here are just different types of processes. And then you get to the fully compliant voyage plan that actually has a full approval process within it. So great thing if ever your instructions change and you need to regenerate a new passage plan, then you just click optimize and recalculate, and everything in the document gets updated. Huge amount of cost savings and time savings for the crew on board to be able to look and operationalize these changes. So I'm just gonna skip back. So from this passage plan, kind of where this is very navigation focused, where we went next is to say, just a quick second. Yeah, is to say, so if we went from this passage plan and started to create very specific events, so here you see a waypoint table with the traditional kind of navigation points and all the speed, the UKC, all the elements. And this is what we've done for environmental, is create active timelines. So this is actually taking MARPOL regulation, port regulations, company specific, so depending on what equipment you have on board, and present your voyage passage plan actually as an operational timeline. So you can see very clearly, this can be viewed both in planning mode or in while actually live, while navigating. A lot of our customers now have that on the tablet, or they're actually viewing this in the office or getting alerts against it. But the biggest thing is it finally allows you to put time to them, which will then allow you to log actions, alerts, and it's very, very clear for the crew to see what they can and cannot do. And that's currently being added to different types of work streams of actions that would need to happen. So here we can link voyages together as if required. In this case, this is a use case for cruise ships, so they prefer to view things in a voyage rather than just a specific plan. And then create all the way here at the end of these voyage schedules, which can be shared through all the stakeholders. And again, the big value is if something changes, it's 2-3 clicks and everything gets recalculated. If there's anything for safety of navigation or compliance issues, it gets flagged automatically. It blinks red, you can see it very, very clearly. So it's been a huge kind of time saving and cost saving for a lot of our customers to be using this. And I think it's an interesting way of looking at operationally. So if you give flexibility, then optimization becomes easier. So just kind of go back, and that's very much kind of the approach that we've looked at. So to look at how can I go beyond passage plan, but using the same workflow, creating dynamic events, and then through live on the ship, logging the action, and then allowing a full kind of continuous improvement and control loop, you have something that's quite clear. So you see at the top left here, very clear during the passage planning process. This is another environmental example, but red, green, orange, what you can and cannot do. Adjust your plan accordingly. Then actually monitoring it and exchanging that information through a schedule that can be shared through the voyage stakeholders. And on the right side here is actually by merging it with logbooks, you actually now have, in this case, this is a non-automatic discharge of build water overboard. So then you can actually prevent risk of seeing, well, did the action take place where it was supposed to? If it didn't, why? But you're all getting that with the same aggregated data in one place. So this has been very much appreciated by our customers. It's an area we're continuing to expand upon. So to look at what type of other operational workflows can we look at optimizing, and how can we bring that together? So thank you. So that was the gist of it, of how we think we can go beyond passage planning in order to create a better ecosystem for sharing and ultimately look at operational efficiency that way.
Thank you very much, Nicholas. Very interesting. Very interesting strategy also. I can see the usefulness of combining these tools into one. For the if we look at the way you optimize routes, can you say a little bit about it? So there was some possibilities to avoid Höegh and other stuff, but the initial route, how is that created? Is it created from the vessel, or is it something that?
Yeah, so I think it's created from algorithms that DTN have. So there's different ship-specific models, and also different equipments as far as the how they perform under certain weather conditions. based on these models. I think there's 47 different ship-specific models currently and growing. And then as you project weather onto them, then it reacts. And it has other layers of intelligence with it, such as actually looking at linking it with navigational charts so that you wouldn't be going into areas that are not supposed to. So that's how that's done.
Okay. And the weather is also coming from DTN, you say?
Correct, yes.
Yeah, okay. All right. So do you have any like now we can avoid egg areas. Do you know if can you avoid severe sea states? Are there any?
Yeah. So it offers the full. So that's you can actually put the equipments that you have, and that's a big part of looking at compliance is actually shoreside per voyage. You can define specific parameters of weather you'd like to avoid, and they get taken into account during the optimization. But they also get taken into account as you're progressing. In we have a live mode, so as you're monitoring and receiving weather updates, then you basically are also monitoring for those predefined factors.
Fantastic. It sounds like it's a very useful tool. Thank you very much. Thank you for the presentation. Very interesting. We have another presenter now. From Höegh Autoliners, we have Atanu Maiti. Atanu has sailing experience on board different vessels, but then he's been working with shipping, trade, and logistics with over 50 years of global experience. He's working with performance management and financial goals. Please go ahead, Atanu, and show us your presentation.
All right, thank you, Soren. I just started sharing my screen. I had some connectivity issues, but are you able to see my screen?
Yes, we can see your screen.
Okay, great. All right, I will speak about the decision making on the ship speed variation, and with the previous presenters discussing a lot about route optimization. I will have a little bit different approach and perspective because of my background. So I will start with introduction here of myself and the company where I work. It's Höegh Autoliners. It's a leading RoRo owner, operator with global presence. And
excuse me, Atanu. The slides are not switching when you're switching slides.
Okay.
We don't have your presentation mode.
Okay, I think there is some IT problem, but then I will request the admin to share the slide then.
Okay. So if you can unshare your screen again, please.
Yes, I'll stop sharing my screen. I will just speak on the...
And then we'll get the technical team to show the presentation in full screen mode, please.
All right, I can see.
And so can we. Please proceed. Thank you.
Okay, thank you. Next slide, please. Oh, yes, thank you. Going back to the introduction, Höegh Autoliners is a leading RoRo owner and operator with a global presence, operating worldwide trades. We are one of the most fuel-efficient fleet in the PCTC segment. And just an indicator is that we have achieved an improved carbon intensity of 37% in our fleet since 2008, the base year. In looking into the future, there is a launch of Aurora class, the first ammonia-ready vessel in this segment. So we are looking into that option quite seriously. And of course, there are other long-standing relationship with the customers and the global organization. The key metrics are we are operating 40 vessels and carrying 1.5 million car equivalent units, 11 global trades, and more than 3,000 port calls. And importantly, in line with the theme of our discussions today, we are committed to the sustainable shipping. I mentioned about the CII, but there is also a goal of achieving zero emission target by 2040. And there are other initiatives and focus on protecting the life below sea and responsible business partner, and also providing good working environment. Next slide, please. Yeah, before I start about talking about the speed variation, my perspective will be very much from the commercial operation aspect of a shipping business and how the speed is benchmarked and how the speed variation happens thereafter. In the speed planning process, we need to go a level up, really, when we talk about the benchmark for the fleet and the voyage. The speed planning determines the, in case of a liner, which ends up in, checking a few parameters like the service quality, the transit times and the trade lanes, and also the next click, please. And also the voyage results, which has got a very important metric like the earning per day, mostly valid for the time chartered vessels, but I think it's equally important for any shipping business. It's not only for the current voyage, it's also important that how we adjust speeds or set speeds for the to ensure that we have a next employment ready. And thirdly, the speed setting results in the carbon intensity measurements, which is the EEOI and AER, which I'll come later. The pricing is another important outcome of how you plan the speed. There are the trade, time chartered vessels and voyage chartered vessels, and there are various considerations that must be taken into account when we set the speed and decide on it. So there is a complete process and background for it. It's a rather complex factors that are involved, and there are many balls up in the air. So it's how do we handle that is the question. And whatever we do, there will be a financial impact. This is a typical scenario where just showing what is the optimum voyage speed, which is commercially the best case scenario that gives the best earning per day. If you see here, the freight revenue of 4.7 million and bunker price 560 in that condition, this vessel's voyage would be optimized at 18 knots. If I go to the next slide, if the freight revenue changes to say 3.7 million, while keeping the bunker price the same, the speed becomes 15.5, and if the freight revenue increase 5 million, it becomes to about 19 knots. So the freight revenue is an important factor that how much you're earning per day as compared to how much you are spending per day. If you move on to the next slide, please. Also, the bunker price has got a similar impact, but in a reverse, effect. If you remember, for 4.7 million, the optimum speed was 18 knots for $560 per metric ton. When it is 620, the speed would be 17 knots, which is optimum. And at a lower bunker price, it is 19. In short, I mean, as you see, the optimum speed planning, the benchmark that we do for the fleet and the voyages, which is more on the higher level, depends on the next employment and the service flexibility and the tonnage availability, which circles back to my previous point on the fleet, how you set the speed for the fleet itself. However, when it comes to speed variation, this all speed planning is subject to many changes, which is driven by the commercial reasons. And and once the fleet speed is set, there are during the voyage execution stage many more factors that affect the speed variation. It's important to note that the optimum speed changes almost on the daily basis. I mean, if there is a change in the voyage status, the optimum speed will change for the voyage. Next slide, please. Well, I will not go in much detail with this slide because you have spoken a lot on this. The main highlight is that this is again optimal weather routing scenario where the dark line shows what is preferred over the other, and it depends on the vessel type, the sea margin experience, the seasonal variations, and how we monitor the performance and analyze and implement on board. Next slide, please. And if you see the headline, this is exactly what is the question, that how, as a commercial operator, how are we implementing that on board? Do we have tools to really implement that on board on a regular and continuous basis? It's definitely not the uniform speed, but we understand that it is best to keep the uniform power or the torque by making a governor setting. But all vessels do not have that kind of monitoring system. So we might land up somewhere between, somewhere keeping the, uniform RPM. The next step, please. The result of, what I want to highlight here is the speed variation is basically the outcome of the best ocean routing, mainly aiming for a particular arrival time and improved consumption, which in our case we have recorded at times up to 10 to 15%, depending on how severe was the weather. There is a serious consideration of weather routing with respect to the ship and the crew safety to avoid any structural damages, and lastly the cargo safety. I highlight also this implementation on board, that we can put forward a lot of tools and routing options, but most important is to make sure that the master and officers on board are able to implement it correctly. As we know that on from the bridge there is an instruction where we can set the RPM, and how we can synchronize that to make sure that we have the right and the most optimal route is extremely important. So speed is not important, it's mainly the outcome here. Yes, please, the next slide, please. When deciding on the speed for the voyage and the variations, there are several commercial risk assessments. For example, the laycan of the cargo, which has a range, the booking changes, the new inquiries, and synergies with the customer's supply chain, and how good the network efficiency is between the feeders and our own tonnage. And last but not the least, the competitive landscape. But considering all factors, the main aim of the commercial operation would be ensuring that we are able to maximize the revenue for that voyage. What we want to avoid is we want to avoid loss of cargo. We end up at the wrong time, then we lose cargo. We end up too early. We will be idling between the employments. And if we are not considering all these factors, we would also miss out on the scope of optimization of the voyage, if any. And lastly, the capacity utilization. You may not have only one ship. You may be we are operating more than one ship. So how are we utilizing the capacity of the ship for the voyage and for the fleet So these will also come into the decision-making process. Coming to operational risk assessment, one of the major voyage costs will be the port operations. And I like to highlight a few points which we must consider. The port and terminal congestion, there has been plenty in the last year and also continuing to be so. Port productivity and the delays, and the standard and overtime charges. In some ports, you land up, at night, you may pay as much as 100% of the normal charges. And how the port and terminal systems are, how sensitive they are to your changes, how quickly the port will process the changes of your vessel's ETAs. And lastly, the service agreement with ports. It can happen, it's mostly with the liner trade, where they may have fixed windows and we may have to land up at those times, which will prompt the speed decisions. The outcome of this is just-in-time arrival, improving the sea to port ratio, which means we minimize the time in port and maximize the time at sea, which means you can lower the speed. The voyage cost versus bunker experience versus the bunker expenses in various scenarios. For example, the overtime, where you may have to do the cost-benefit analysis. And on a little bit higher level, if you understand all these parameters and dynamics, we are able to determine how we should review the supplier agreements, for example, port and other service providers, to have the best voyage. But in summary, it's all of the operational risks must be taken into account to decide on the speed. Next slide, please. Then coming to the technical factors, the vessel performance, of course, the first one. How is the characteristics of the vessel speed curve and how they behave in various conditions? For example, how hull fouling and other effects of and such effects will change in the operating conditions. How is onboard monitoring systems and human decisions linked to that? We are also we should also consider the bunker planning, the bunker price and the quality when deciding how the voyage will progress. At times, we may have to deviate the vessel to ensure we have a better quality fuel, and this is a bit of concern we are facing in recent times. And with new kinds of fuel or new specification of fuels that are coming in the market. Of course, planned and unplanned maintenance and docking and surveys are also to be accounted for. Other factors, for example, the war risk areas and the security, where the speed must be adjusted accordingly. The insurance premiums, it depends sometimes on how much time the vessel is in a particular area, and the premium is set up as per that. Safety of navigation and the local regulations in the coastal areas. And not to forget that the crew and the rest hours when there is a very busy ship in coastal areas. Well, I just listed out many factors, and as I mentioned, there are too many many factors that must be considered. So how do we manage the speed variations when we are executing a voyage? The team must have a commercial mindset and the experience and understanding of the business. There must be a real-time involvement of the persons involved for immediate decision making, and the company organization must allow for such setup. The onboard management, the training on board, where the master and crew should be aligned to such requirements and requests from shore. The tools, the digital tools and the analytics. Of course, we all like to have as much information in proper order and without doing our decision-making process. So the right tools and relevant tools are most important. And also the record impact of the decision-making. to reflect upon how it has gone to develop your experience is very, very important. On the reverse side of the coin, the next step, please. On the reverse side of the coin, it's very important to understand what happens if there is no decision or delayed decision. There is a loss of commercial opportunity. There is a direct impact on the bottom line, where you may be spending more on the fuel or the port cost. And thirdly, you are going to increase the carbon intensity index, which is environmental impact. Next slide, please. Just a few words on the future outlook then. I'll not go into the detail, but the energy efficiency design index, EEDI and EXI in force are extremely important to consider for how you operate the vessels. And it is dependent on the engine power limitations and hull and propeller and rudder efficiency and power saving plans on board. But very relevant to what I have been talking about, the speed decisions, the CII requirements will need operational efficiency, which is guided by the EEOI and AER. As most of us know, that IMO's operational rating scale will come into picture, and therefore managing speed and managing speed variation would be a very important tool for compliance of this. The impact of the speed setting and the variations will equate to the efficient operations. Of course, the future fuels and future fleet will be a game changer. They may not emit as much of carbon as the normal hydrocarbon fuels do. So that will be something to watch out for. And lastly, the digitalization, is an uptrend in today's shipping world and very welcome. But this is for the personal, performance data analysis, which I believe is moving towards a predictive and prescriptive option rather than just a reporting one. But it is important how we adapt to such new technologies without taking out the human element and the decision making. I will just conclude by saying on the topic of ship speed setting and the variation, that there is a lot of background in decision making as to how you arrive at what speed to rightly go with. And this has got not only operational implications, but also some tactical and strategic implications for the business. So thank you very much.
Thank you very much, Atanu. Very interesting, and the financial perspective, getting that into these considerations here. So just one quick question. Now you mentioned all these CIIs and EXI and the upcoming regulation. What about one thing that that's going to disrupt the commercial market also, and then I guess also emissions trading, right? So soon, when you're sailing in EU, you'll have to have a CO2 quota, and that's also something that's have to be taken into considerations, right?
Yes, absolutely. It is extremely important to be future ready. Otherwise, the vessels will not be tradable. So the implications are quite serious. So it is important, just very relevant to my topic and also yours, that whatever we are discussing is all being pulled in the same direction. That is how you can lower your carbon emissions and how you can improve your ship's design and what tools are suitable and how we can adapt them. I mean, it's very important that the tools, just presenting the tools may not be good enough, but we need to make sure that we have to adapt them. A typical example is that we are still debating on whether it is uniform speed or uniform RPM or uniform torque, which should have been solved by this time, but it is not.
Okay, thank you. We'll get back
Okay.
to you in the Q&A session. Please stay tuned for that. And now we have the final presenter, and this is Giannis Papageorgiou, who is an independent consultant for the time being. Giannis has been working as a vessel performance expert and a subject matter expert in force technology and latest in Maersk. And he will present on AI and other technologies review on voice optimization. So please go ahead, Giannis.
Yes, hello. So I will just share my screen and I hope you see it. Do you see all well?
Yes, we see
Yes.
it. Yes.
All right. Yes. So thank you for this invitation. And I would like to take you, to start a bit from, from what it's our needs as an industry. As all of you are aware, IPCC report is out like some months ago and is indicating direct action. And maybe we should have taken much more actions yesterday, but maybe it's not too late. They are saying, hopefully. So COP26 is next month. With important decisions will be taken there. This is the symbol of the COP26, and on the right, the sphere. I like it. It's indicating us, the globe. I mean, it's represented like fluids, wind and water, and that's where we are operating with the global fleet, and we are trying to operate there among these fluids and optimize. So optimize the routes, optimize our accuracies to make what is possible. So I strongly believe there is no time for comfortable comfort to us as engineers, and we must take actions. Seeing things like this, it was from last year, San Francisco looked like Blade Runner apocalypse. I want to start taking just one step back to think historically. I would say that Lewis Mumford was one thinker, philosopher, had a very interesting passage in his book, The Myth of the Machine, discussing the history of technology. And he's mentioning the navigation of the seas. It was for the humanity the base of science, of bringing the scientific method, from looking at the stars, or from taking measurements of how the water is, how much is the depth, or simply the logbook of the ship, or the weather, of course, and trying to cross to the next island or to the deep sea. Then you would need to note down how the weather was and find favorable weather patterns, for example. And as we are talking about weather, I think it's one of the most important points, of the technologies that we should have today that are the tools to help us optimize and should not be neglected in these forums. I would imagine you have the picture of the magician with the crystal ball in the past trying to predict the future. For me, from my mind, that's the meteorologist that he's trying to predict the weather a bit in front. It is actually giving us many different weather providers. That's the point. We are having maybe some free data, and we are having companies having more advanced models with specific areas, specific, let's say, for example, the currents in specific areas, or local models that have improved accuracy. So these are very important decisions for the navigation of ships. And as well, another point that it's very important is like we have very long routes typically. Some presenter before showed an example of a route from Singapore to Santos that takes longer than what the accuracy of the current weather models would predict, so maybe longer than 9-10 days. And then we have to base on climatic averages, which are based on decades of data, to have some prediction of the optimal weather routing. But there is a risk of these climatic averages are quite outdated because we have climate change. As I'm talking about the weather and other technologies, I mean, I would say some news, probably you heard them, but it's interesting to discuss them. I think it was some of the news that AI was able to predict accurately rainfall and beating some of the physical models that they were available in the market. It's some in nowcasting, not in forecasting. So you can see in the upper right sub DGMR subplot, it's closer to the target compared to the others. That was the result presented. And yeah, an example on the left is another one that it gave very good results in the shape of proteins and will try to help all the biologists. But how does AI work? I mean, I think it's also important to discuss that a bit in high level for the understanding of many people in the industry who didn't have the training so far and hear a lot of words. It works mostly through pattern recognition, simply, and it's trying to give predictions. So if it's doing things that the machines are good in doing, a lot of computations trying to see things through that that we cannot. So I will take again a step back of the industry. We have the connected vessel today, right? The connected vessel. It's also a not new thing. I mean, here I see an example. It's a 50 years ago this ship was built. It was 71. It was a research vessel of the USSR. Its mission was to try to detect interballistic missiles. So if a nuclear bomb is flying over the Pacific Ocean, for example, I can guarantee you it was fully connected back then to give all the alarms to the shore. So then what is used there is telemetry, meaning that try to measure from distance, like trying all of this technology. The controller is far away and we are having an overview of what's happening there. Ships are mega machines. We have economic interest of these huge structures to know how they are used. So we can finally have remote control. That's the vision of having the connected vessel. It's the need is to have control of what's happening. And having the vessel connected, we have abundance of data. So how can we use them smartly in voyage optimization? The heart of the problem, I would say, and I wanna make that clear, it's having accurate fuel tables, power against speed in every condition, like wind, waves, water depth, whatever you are trying, you are going to sail. We have fuel is if we can predict it accurately, it's helping so much. Is the biggest cost, is defining how much we are emitting, and it's only the way if we are able to measure as well accurately that we can have a benchmark to check if we are improving over time. So having accuracy, I mean, I would say good systems should give as well accuracy levels that say we are confident around that we are sailing and indicating, where we are standing in this speed, for example, or in these waves or winds. There are many ways to do modeling, traditionally from full-scale data obtained, plus corrections in the office, other more scientific, other less they are doing. There is, of course, the approach as well from the lab for example, model tests or CFD, hydrodynamic or aerodynamic, in waves, still water. We are trying to simulate the physics from the physics laws in small scale and take it to the bigger scale. But we have as well the modern ways as well. It is, one can ask, what about all the data that are connected? Can we use the machines to learn from the data that we have abundance of them? So yeah, there are good trials on learning from the data. So the machine learning models that somebody can apply are trying to learn the physics from the data itself. They don't know it before, so they need to learn them themselves. So although this approach has certain dangers that some were indicated, as well as I saw interestingly on the questions of this Q&A chat of this forum. One could be the sensors data quality. We can have erroneous data coming and storing, so the dangers of rubbish in, rubbish out. Or we can have also, though, and that's more critical, like the need to train the models on unfavorable conditions. So if vessels are operating in a typical speed, let's say, and draft profiles, or in some seas that there are typically no strong wind and waves, the model itself does not know how the vessel is going to behave in these conditions that is not trained. So you need a training over all the operational possibilities of the vessel and the probable possibility, like even in high waves, to learn wave resistance. So this I wanted to show just with here on the two-dimensional histogram that, let's say, higher frequency is the red, and we many times would need to operate in the blue area. So it's an empirical model and it needs to learn from what it's been trained at. So it's like doing a full-scale experiment, which can be costly, very costly for fuel and pollution. So, but there is the approach of hybrid models that somebody can take the advantages of both and try to use as well all the knowledge that we have from naval architecture methods on modeling wave resistance, etc., and what do the data show that we expensively take back to shore. And we are trying to reduce uncertainty with them. I will switch now to safety. And Soren, I think in your presentation, you raised exactly the points that I would like to do. Because it's also a very important issue that we are not talking a lot about. It is, I mean, we are talking about performance, but there is the efficiency, performance, and there is safety. And safety, we see, for example, last year, I mentioned the example of containers. We had a 7 years high. You see the data points there. For 2021, it's like from April, the data. But yeah, I mean, we can do much more, I believe, as an industry there, and the systems, the navigation systems, should be able to provide warnings to the crew and to the office that the vessel is operating in some conditions, in some seas, that dangerous ship-keeping phenomena can happen. For example, like graphs like this, showing them that you're inside the area, like there's a polar diagram, heads and speed, and yeah, showing you that you are probably going to face parametric roll if you continue there, if you don't speed up or change your direction. So and it is very important as well there for this to be accurate, to have a good overview of what weather the vessel is facing. The weather forecasts, as well somebody said before, are not always accurate. It's some tools that we have to predict, but many times can be off. It's hopeful if we can use wave radars to scan the sea in front of us to see what is coming and to give warnings of what a vessel actually is going to face short term. At last, another topic that I believe that it is in this, we can discuss as well the future of navigation, the future of resistance and propulsion. How do we decarbonize? We decarbonize not only by switching fuels, I believe. We also need to reduce the energy that the vessel needs to sail. So we really need less fuel, or we take some energy from another source, right? The idea of the blades that's imitating nature that some fish have. Example, we have seen the industry looking at some specific vessel types for the moment, of course, but they can maybe having blades on the side like the shark here, or I mean adaptive to the design, of course, of the vessel, can reduce a bit the added wave resistance by reducing the vessel motions in pitching, and they can be subtractable or not. And yeah, we can do complicated stuff. And maybe in the future, who can imagine maybe that we can switch from the propeller, maybe something that can be more efficient. And at last, the industry, I would like to say, do not forget the wind and wind systems. Here you see a picture from people that sailed thousands and thousands of years ago to Polynesia. They managed it with a single sail. Still, I believe as an energy source, it has to give us some savings in the types of vessels, in any type of vessels. But yeah, I think that's maybe a bit high level, and I would like just to underline that what should a shipping company should do at the moment, like I believe, like be ready for digitalization. Many companies are not, I believe, they don't have well-structured databases. They are doing ad hoc analysis, one-off, everybody with an Excel sheet, or yeah. And these are problematic things if we are going to use all the data that we have. And as well, very important for me, it's the issue of cooperation. Don't be afraid to share data. If we need to decarbonize and take actions, we only need cooperation to change technologies, right? And we need the combination of many human and machine minds to achieve this and get savings there. So play with open cards, and if somebody is skeptical as well with competitive advantages of the companies, they will come from the technology advantage that the forerunners are achieving. So yeah, that was from me. I think we have a long way forward. The sea was always here. The people sailed it, transport their goods, transport themselves through it. It will be here, and we need to adapt to the needs that the scientists are saying to preserve our planet as well. But yeah, thank you very much for this.
Thank you, Giannis. Thank you for a very interesting presentation. And you are definitely looking at it from a high-level view, and showed us some of the options that's available for the future. And I would like to invite you all now to think about this, because now we have heard, yesterday we heard about actual problems that we were facing with regards to weather routing, with optimization of routes, and there were software providers providing some knowledge about what the products were able to do, and there were ship owner operators presenting what were their problems that they were facing. And today we have heard about also the commercial aspect from Atanu, and we have heard from Nicholas and Angus complete systems, including digitalization, AI, and you just mentioned machine learning also, Giannis. So what will the future bring for what we're doing here? Because there's the commercial, there's the safety, but now there's also the environment. I think the environment will be something we have to take more into consideration. We have Atanu, he mentioned the EXI. Probably existing vessels will have to reduce speed a lot, while you reduce power and thereby also reduce speed. We have the CIIs, where it is a performance parameter, but it is also an operational parameter. So how do you operate your vessels? It has a big impact on your rating for the CIIs. And then there's all these alternative fuels. Now we already see vessels that are dual fuel LNG vessels. They are looking for places to bunker. So is bunkering an optimization thing? So what do you see as coming up as the next thing we need to have in this area? I don't know if we could start with you, Giannis. Do you have any insight or something you think you want to share with us on this?
I mean, for my point of view, I think the companies, as I said, they need to organize and digitalize much more, and there is way forward in order to give, for example, I hope that the sensor data are used for as well the reporting and the checking of the CII operating indicators, and because otherwise, if it's based on reporting, it can always have inaccuracies inside, right? And an intentional changing of numbers and all of these things. So I hope that this is coming, and so we can achieve savings when we can trust the data, for example.
Yeah, so trustworthy data, more digitalization.
Maybe with cryptography, and I don't know what methods could be applied to secure the trust, but I believe that they are important points to make.
Thank you. I agree with you. Atanu, do you have a view on this?
Yes, yes, Soren. I mean, I can only add that, as you mentioned, it is the environmental impact is coming to the forefront now, and the commercial perspective will never go away. So that is purely the reason why the shipping companies exist. So it's important to balance that, and the data, the good data, and the tools are very important to support that initiative. And I believe the shipping companies will or are already doing some investments in the technology for better designed ships. So that is the core of how they can tide over the problem. But the digital tools are most important. And only thing I would like to guard against is that if it is a huge overdrive, it should not remove the human element. At least I don't see that has happened yet, that we can completely automate. It may come in a distant future, but we cannot remove the human element as yet.
No, thank you. Nicholas?
No, I think it share the point of view of what was mentioned before. I think technology needs to be seen as an enabler, not something that replaces. And I think that performance will always have a new flavor, or optimization will always have a new challenge. It's the nature of the maritime industry. So how do you put in place as a company, either through structured data, a way of kind of making optimization part of your own continuous improvement, and doing so incrementally by don't try to tackle it all at once. So I think as part of digitization, structure your data so you could continue to use it going forward, but being realistic and doing it through incremental steps and doing it continuously, I think will yield long-term results.
Yes, I agree with you. Thank you very much. Angus, do you have a view on this?
Yeah, I mean, I agree with everything that's been said here. It's funny, and it will certainly probably seem strange as a guy working in an AI tech company when I say that I really don't think the next few years will be about big technological breakthroughs. That's no longer the problem. It's now all about implementation, creating pathways, creating systems, and social. And it's interesting. A lot of the comments, quite rightly, have been saying, "Are we not? We must continue, as you said, Soren, to consider the place of the human in this." And I mean, from our company's perspective, that's exactly where we are. We've just launched a big initiative called the 10% Initiative, which you can find online, which is basically about precisely this. It's about taking the technology that actually already exists, quite recently, but exists because we've managed to get there, and giving companies at any stage of their decarbonization journey a nice, easy, risk-free pathway to implementation and savings. So that's very much what's on our radar.
All right, very good. So how because now we are talking about digitalization, we are looking at sensor data, and we have talked about the human element in this, because we are in fact working with humans on board some advanced technology vessels. So how do we not skip them in the process then? I mean, because if we don't need them to get the data, do we then how do we get them good advice then? Is there any perspective on that?
I think it starts with finding ways of not duplicating the work. You just take the principle of, I know we have sensors and maybe better way of doing digital twins and that analysis, but if you just look at data entry from a noon report to filling a logbook that is mandated, and 2 different medias, the data is already there and already being collected. It just needs to be opened up and used in a different way. So I think that's the biggest way of making sure people kind of jump on the bandwagon for it, if you want.
Yeah, I agree entirely with what Nicholas has just said. And what I've seen is that it's important because we all recognize that there is going to be a shift in terms of the work that is done by humans and the work that is done by computers. But the important thing for a company to really embrace this is to have a plan as to which bits go where. Because if actually you are if you're responsive in your approach to this change, then it means there will continually be fights between humans and robots, effectively. I mean, I'm not forecasting the apocalypse here, but that's basically what happens. Whereas for companies which have a plan and say, increasingly, this is what will be done by the humans, this is what will be done by the automations, that solves a lot of problems, I think.
Yeah, and from my perspective, I want to underline the importance, I mean, for how to include the human, I think, and how to include the people on board as well. It's very important. It is, I mean, for me, it starts with education as well. Like, I believe there is much more space on training the crews, training the people, continuous education, and understanding new technologies. Like, if people are able to understand physics, machine learning, or things that are happening, things that they maybe didn't have in their university, I mean, the companies should train them, so, and they will in the end benefit from it if captains understand how to optimize against the waves, also it will be more safe. So the human element, I mean, it cannot be just the machine said that, or the code said that, or the office said that, and then let's do it. that's let's have better communication, but it needs all the people to share the knowledge and understanding that makes sense to do.
Yeah. Do we have a perspective on this also, Atanu?
Yes, on the human element, I mean, I did mention that the crew on board, the onboard management and the training thereof is very, very important. In practical terms, I am aware and I have faced so many times that each master on board has handled the same vessel quite differently. And when we talk about more data, if the data is extremely accurate and extremely real time, then it is perfect. But I don't know how much time it will take to perfect that technology. You are giving some predictions and the master is acting on it, but it is not a real-time data. Suddenly the wind can, the wind can change or the swell can change. That has not been predicted. And if master is completely relying on the data, which will take a long time to reach to that level, then we have not done our job. So it's very important that master do not forget his weather books and how to read a weather chart, and also from my angle must understand the commercial perspective, including safety of the ship and the cargo. So it's very, very important to do that.
Yes, I agree with you. So my outtake from this is that when we digitize more digitalization, we need to remember the crew. We need to keep them in the loop and to develop our tools with them. Thank you very much for those perspectives. I think we will end this session now. I want to thank you all for joining, and thank you for presenting your topics. It was very useful, combined with what we saw yesterday. I think this has been 2 good days to discuss navigation and route optimization. And I think what we have heard from all of you is that we are progressing. We are working in the right direction, and I think we are creating more and more useful tools and using the technology that's available for us to be better at optimizing the routes that vessels are sailing. So thank you very much for joining here. Please have a look before you go at the Q&A sessions. There might be some unanswered questions here and there, but thank you for joining this conference today.
Thank you very much, Soren, and everybody. It was a pleasure. Thank you.
Thank you. Thank you, Soren. Thank you, everybody. Bye.
Bye-bye.
Thank you very much. Appreciate the presentation. If there's any questions, please feel free to reach out.